Welcome all of you. Continuing with the life cycle assessment part. So earlier we saw like what are the different phases of life cycle assessment. The first one was goal and scope. Second one was life cycle inventory. Third one life cycle impact assessment, and the last one was interpretation. So today we will see different types of LCA. Like there are mainly two types of LCA: attributional and consequential. So those two we will see. And then there are many other types of LCA on different bases, but there is no like standard fixed number on types of LCA. Like you would find social LCA somewhere coming up in different books, but the two main ones are attributional and consequential that we will cover in this course. LCA scope and application. Like what is the scope of things which LCA covers, and what are the possible sectors and types of application where LCA can be used for, followed by some case studies. So there are two types of LCA: attributional and consequential. So attributional LCA, it describes the environmental impacts that are directly associated with the life cycle of product under current or average conditions. So if there is any company operational and producing some product using some technology, and they have some system of distribution, selling it and disposal, and for that existing system, if we are conducting the environmental impact assessment applying this tool of LCA, that kind of LCA is called as attributional LCA. So if some power plant is producing 1 kilo, like producing electricity, so if the environmental impact of using 1 kilowatt hour of electricity today, it is 1 unit of electricity, right? What is the environmental impact of using this function unit today? That can be considered as a attributional LCA. So some power plant is producing it and we are just using it, so we need to find the environmental impact. Now if we take one example in India, or just like a random example where a grid mix, if it is having 70% coal, 30% renewables, and the average emission factor for this combination, if it is 0.7 kg CO2 per kilowatt hour. So what will happen for 1 kilowatt hour? What would be the emission using attributional LCA? It will be 0.7. Actually, basically, it will be 1 into 0.7. So for 1 kilowatt hour, because per kilowatt hour 0.7 kg CO2 is the emission. So total emission for 1 kilowatt hour is 0.7. Now this type of LCA, it describes the current system, the existing system. Second type of LCA, which is consequential. It evaluates the change in environmental impacts caused by a specific decision, action or change in demand. For example, like in the previous case, we calculated the CO2 emission for the average grid emission factor. Now suppose if there is a norm which comes that you should be using only renewables, or there is some decision taken to change the source of fuel in the company, like maybe they switch from coal to gas or oil, or maybe there is some change in the market demand because of which there is some change in the process. So that will change environmental impact. So that is called as consequential LCA. For example, if demand increases by 1 kilowatt hour, so in earlier example it was the demand is 1 kilowatt hour, find the emission factor. Now if the demand is increased by 1 kilowatt hour, which power plant will actually increase the output and what will be its emission? So generally the marginal plant is the one which supplies when additional power is required, and it is typically the one which is having the highest share of the grid. So if coal power plant has the highest share of the grid, then marginal plant is the coal one. So when there is like say less electricity, or when there is additional demand, then that additional demand has to be met by marginal plant. So in this case, coal power plant will meet this additional demand of 1 kilowatt hour, and coal emission factor is 1 kg CO2 per kilowatt hour. It is just the assumed value compared to the average grid emission factor of 0.7 in the previous example, because there we had 70% coal, 30% renewable mix. Now here it is for pure coal, it is little on the higher side. So the result for consequential LCA for that 1 unit extra would be 1 kg CO2 equivalent. So emission is higher in this case, but this type of calculation is called, or LCA approach would be consequential LCA, which is responding to some change, maybe it will, and that change will change the environmental impact. So if we have to just summarize it, attributional LCA, The result was 0.7 kg CO2, and it was because it used the average grid mix, which was current situation. But consequential LCA is for the future situation, like suppose if demand increases by 1 kilowatt hour, and if that is satisfied by the marginal power plant, if that is responding to the demand, the emission would be different. It is 1 kg CO2 which is higher side. Okay. So, those were the two types of LCA approaches. Now, coming to the scope and application. So, what are the things which are included in the scope of LCA and where it would be applied or how it would be useful in different sectors. So, LCA, it promotes the understanding of product manufacture and delivery system, because we talk about the entire life cycle of the product. It includes not only the manufacturing, but also delivery, consumption and disposal phases also. But so far as responsibility of industries is concerned, primarily it is with respect to manufacture and delivery. So, that understanding is promoted by LCA. Highlight value chain efficiency opportunities. So, throughout the life cycle there are 5-6 like different stages, and under in each that stages where are the opportunities for value addition, okay, for value chain efficiency highlighting, that can be done by LCA. It ensures that changes do not shift the burden, but improve the overall system. This is very important point, because what happens if there are let us say three processes in a system, and we get ABC, okay, and if total systems emission is 1 kg CO2, and if A is contributing 0.3, B is contributing 0.5 and C is contributing 0.2. Now, we know that the contribution of process B is high. So, the solution can't be in such a way that to reduce this emission factor of B, if we make it to let us say 0.3, but while doing that 0.3, we cannot make this as 0.4. So, we cannot be shifting burden from one process to other process within a system. That won't be recommended by LCA, and instead LCA focuses on improving the overall system. So, that is what called shifting the burden. Highlights trade-off between different factors and processes. There are several factors in a single process or many processes in a system, and if there are any trade-offs, those would be highlighted by LCA. If we have to compare two or more systems which deliver the same service, that can be done easily by LCA based on their environmental impacts. For example, if we need to buy the air conditioner, there are different companies supplying it. Okay, it comes in different capacities, different ratings, different prices, different reliabilities, and like after sales, after service options. So, there are many factors based on which you can compare those systems. But then so far as LCA is concerned, like the environmental impact is concerned, it will be related to mainly to the specifications and the efficiency and the type of coolant gases or chemicals they use. So, there LCA can be a useful tool to compare two or more systems. Benchmark progress, provide impact data of individual units and entire process. So, if we have a big system, if we just take it as a one single system, the entire system will have some input and some output, for which life cycle assessment can be performed, and one final value for overall impact can be obtained. Now, if this entire one system has several subsystems, then each of these systems will have inputs and outputs. So, by performing LCA based on the detailed life cycle inventory, we can get the environmental impact for each of these subsystems. And when we get the environmental impact of each of these subsystems, if we just do the summation of all the subsystems, the total should match with the environmental impact of the entire system when calculated as a single block. Okay. So, that happens in the life cycle assessment if it is done, when it is done carefully and correctly. Also, it supports environmental claims of a company or any industry, because if they are claiming that they are emitting this much CO2, this much PM 2.5 or PM 10, if they have this LCA analysis done and the results, that will help support their claims related to environmental emissions. So, there are many things which are beyond the scope of LCA tool. What are those? So, it does not measure the performance of product. It has nothing to do with the efficiency or the satisfactory performance of any product. It does not address compliance with environmental laws. Okay, just like EIA, which is mandatory under the environmental laws and regulations, because based on that EIA report, the environmental clearance would be obtained. But unlike EIA, LCA, it does not address compliance with laws. It does not include bricks and mortar of capital equipment. So, like capital equipment, if you remember, in our first or like second phase of LCA, when life cycle inventory was done, we do not include the list of equipment unless it is significantly influencing the functional unit. Per functional unit, if there is a reasonable or considerable measurable change in the value of the equipment, then only we include it. So, it does not include bricks and mortar of capital equipment, does not include analysis on support personnel needs like for manpower and all, HR benefits. So, there LCA has no role. It does not include minor inputs. If they are negligible or minor with respect to environmental impacts, then those would be neglected. It does not provide information about employee impacts. It is not a risk assessment analysis. Okay, life cycle assessment is different from risk assessment analysis, which deals mainly with risk, hazards, some potential what if scenarios. Okay, and it's in slightly different domain compared to the life cycle assessment. It does not define a specific course of action to take. LCA won't define a course of action. LCA will just give us the like possible environmental impacts based on inputs that we give it to the model. Okay. Now, the course of action will be taken by the mitigation strategies, either by the environmental management system or by that EIA team, but LCA has nothing to do with, it does not specify the course of action to take. That is not the phase or part of the LCA. So, it is beyond the scope of LCA. Let us take one case study. We will take two case studies for LCA, so that you know how calculations are done and how each of those four phases of LCA are employed. So, this is for 1 kilowatt, that is 1 unit electricity generated from a coal power plant. So, a typical coal power plant, if we have to consider like a system boundary, here if we say like we are starting from the mining and extraction of coal, that is when the coal is obtained from mines, it is extracted and then it is transported to the processing site. So, not just coal, but other materials that are required to generate electricity with coal, those are transported to the processing site, and when it goes to the power plant site, they are processed and prepared, refined, so that they can be used directly in power generation. And when the power plant is operational, it generates electricity from that processed coal, and once that electricity is generated or power plant is in operation, there are lots of emissions, and that coal which was used, what happens to it after the end of life, like how the byproducts or the waste coming out from the power generation process are managed. So, it is more with respect to coal, I guess here, but for with the purpose of generating electricity. Let us quickly look at how does a coal powered power plant look like. So, a coal is supplied, coal is a fuel, okay. Solar thermal power plant or gas fired power plant, oil fired power plant, all these terminal, like the power plant is going to be similar in these aspects, this equipment. The major difference is the source of heat for generating steam. If it is coming from coal, you can call it as coal fired power plant. If it is coming from oil, oil fired power plant, or if it is coming from gas, it can be the gas fired power plant. So, basically in boiler we use this coal, and when this coal is burnt in the combustor, the heat is provided to water to generate steam, which rotates the turbine, generates the electricity, and then that electricity is transmitted to transformer and sent through distribution lines. The steam, after losing its power in the turbine section, it condenses back to water, which is pumped again to the boiler, and the cycle continues. Okay. The coal, when it is burnt in the combustor of boiler, the stack gases goes out to the atmosphere through chimney. Obviously, there would be some cleaning, some filter mechanism to remove the particulates or trap like SOx and NOx before they are released into the atmosphere. So, that is a typical coal fired power plant. So, you can see there are many components of environment which are directly being used. This coal power plant exists on the land, it is built on the land. Coal is extracted from the mines. So, it is a resource, it is a fossil fuel. When it is burnt, the emissions, the gaseous emissions, it goes into the atmosphere, and there would be some wastage or losses through steam or water. So, we are relying on water also. So, different components of environment are being used here. So, it is definitely going to have environmental impacts, and doing life cycle assessment makes sense for this case study. So, the phase 1 goal and scope. Goal in this case, assess the environmental impact of generating 1 unit of electricity from a coal power plant. That is the goal. Since the output is electricity, the function unit would be in terms of 1 unit or 1 kilowatt hour electricity delivered to the grid. We can't have 1 kg coal, because depending on the system's efficiency or the types of coal, there will be many things which need to be specified. But irrespective of types of coal or transportation or change in system efficiency, there would be the ultimate service that is delivered here is electricity. So, based on service, the function unit is choose. So, 1 kilowatt electricity is a better function unit in this case. System boundaries cradle to grave, because we are starting from coal mining to transport to combustion and to handling of ash after the coal is burnt to generate power. Assumptions: the average plant efficiency 33%, coal transport distance 500. These are just some assumed numbers, or it can be obtained from a real case study. And impact categories, because in this, after the goal is set, you have to set the scope also, like what would be the boundary of system, the assumptions, the categories of impact that we are going to estimate. So, global warming potential, because it is a power plant case study dealing with emissions having climate change impact. Acidification, eutrophication, particulate matter, water use, toxicity. So, these are the impact categories which are being considered for this case study, and there can be many more, like depending on the method that we use, whether it is a recipe method which has almost 18 impact categories, or TRACI or CML method, we can have different number of impact categories. Sometimes it can be on the basis of like the one who proposes the project, or the someone who is interested in knowing what impact categories, like which are the important impact categories for a particular project. So, those impact categories will be definitely considered. So, that was the goal and scope. Phase 2 is life cycle inventory. So, we need to know all the data about coal power plant, how much coal, what would be the emissions. Okay. So, the input output, and it with respect to 1 kilowatt hour, and then some source or nodes. So, coal is consumed for 1 kilowatt, let us say 0.5 kg is coal required, based on Indian coal and efficiency. Water usage is 2 liters, limestone, CO2 emissions, SOx, NOx, PM 2.5 and fly ash. So, that is the data we got for input and output. Some of the things go as input to the plant, and lot of things come as output from the plants. Okay. But both this input and output would form the list of the inventory. Now, the third step is life cycle impact assessment. So, once we know the functional unit, once we know the life cycle inventory, the third step is calculating the life cycle impact, and for that we will need the emission factor or characterization factors, right. So, let us take one example of impact category, global warming potential, GWP. So, the data from LCI, we had CO2 and methane data. So, CO2 was 0.9, methane is this much, and like the characterization factor, if you remember, for CO2 it is 1, because 1 kg CO2 equivalent is 1 kg, methane 28 kg CO2 equivalent per kg. So, how do we get 0.914? We multiply CO2 amount by CO2 factor plus methane amount by the methane's characterization factor. So, it comes out to be 0.914 kg CO2 equivalent. So, under the global warming impact category, this is the impact. Similarly, we can do for acidification. So, the LCI data shows the value of SO2, we know the characterization factor. So, SO2 is same, equivalent to SO2 equivalent, and the number is 1. So, 0.06 kg SO2. Similarly, for eutrophication or other particulate matter, we can use the characterization factor, do the calculation and calculate the impact. Okay. I have not shown here for all like 6-7 categories that I mentioned earlier, but this is how you calculate the environmental or life cycle impact for the inventory. The final stage is the interpretation. So, interpretation is basically analyzing the results obtained from life cycle inventory and life cycle impact assessment. So, in this case, the findings for coal power plant are summarized here under different types of interpretations. The first, like because of LCA life cycle assessment, we can find what are the hotspots or what are the important issues that need to be highlighted first. The first thing is combustion of coal, which lead to highest amount of greenhouse gases, and second is mining. In the mining operation, there are a lot of methane leakages. While extracting coal from mines, there is a leakage of methane in the gases exiting from the mines. Then fly ash can be toxic if it gets mixed with water or if it gets inhaled by human beings. So, there can be human toxicity or water toxicity. So, these are the significant issues: combustion, mining and fly ash, which needs to be dealt. Sensitivity check: for this case study, the distance was 500 kilometer, but if there is a longer transport, it will increase the amount of CO2 emissions. Hence, if we have the higher efficiency on the combustion side or on the power plant side, we can reduce all the impacts. Consistency check: functional unit and boundaries uniform across phases. Yeah, it was there. Conclusions: the coal electricity has high global warming potential and air pollution. That is the conclusion based on the GWP values, because other values of acidification, eutrophication, it was less, but PM particulate matter values was higher. So, it leads to air pollution. And recommendations based on these findings is also a part of interpretation, which tells us like you should work on improving the efficiency, maybe install the flue gas desulfurization unit to reduce the amount of SOx going into the atmosphere, mix renewables, shift to renewables, capture mine methane release from mines, then improve the utilization of ash. Maybe use that ash for making bricks or give it to some cement industry if it is nearby. So, those are the recommendations which are also the part of interpretation, and it is based on the life cycle assessment that we did for a one case study. So, that was all I think for today's lecture. So, what we saw was different types of LCA, the scopes and application of LCA, things which are beyond the scope of LCA, and then we looked at one case study of a coal fired power plant where we applied this tool of life cycle assessment and saw how each of those 4 phases can be utilized and how different types of components can be involved in the interpretation stage. So, I think we will stop here for today. Thank you.